Right, let's take a look at our last section in chapter 1. Okay, section 1.6. Okay, 1.6 is on basically how we can create new functions, okay, by doing things to existing functions. Right, in general, we'll take two existing functions, probably no more than two, kind of combine them together to create something else. Okay, one way we can combine functions together is very simply by just taking two separate functions and adding, subtracting, multiplying, or dividing them. Let me show you an example. Okay, here's one function, f of x. It's equal to x squared. Okay, here's another function, g of x. Okay, it's the square root of x plus 1. And I'm going to create something new by adding them together. F of x plus g of x is x squared plus the square root of x plus 1. There's not really any simplifying you can do with that. So it looks kind of messy, but that's all you can do. Okay, here's another new function we can create. We could take our two original functions and divide them. F of x divided by g of x. It's x squared divided by x square root of x plus 1. Okay, and you could take those two functions, you could subtract them, you could multiply them. I'm not going to go through every example. But that's kind of the idea of what we're doing. Take two functions, combine them together in some way, make something new. Okay, and page 58 in your book gives you some more examples. Once we combine these functions together, all right, we might be messing around with the domains and the ranges. Okay? Each one of these functions has its own domain to start with, and it has its own range. But once you take those two functions and combine them, now the domains and ranges might change a little bit. All right, so what we have to be able to do is identify what is the domain after we combine them together. All right, so the domain is basically all x values that belong to the domain of both of the original functions. All right, once you combine them, the new domain is all x's that belong to both of the original functions. So for example, let's say you wanted to use -5. Well, -5, okay, I can plug it into f of x. -5 squared is 25. But can I plug -5 into g of x? No. That would give me a negatives under the square root. I can't do that. So -5 is not a number that belongs to both of these domains. It belongs to one, but not the other. 2, okay, on the other hand. 2 squared is 4, so I can plug 2 into f of x. 2 plus 1 is +3, so I can plug that into g of x. All right, so 2 is a number that belongs to both of the original domains. Okay, so any question on what I mean by belonging to both and not just one? Okay. All right, so the domain of the new functions, again, has to belong to both of the originals. And if you do any division, okay, if you decide to combine two functions by dividing them, make sure you never have a number that would make the denominator equal to 0. Okay, we are not allowed to divide by 0. Okay, and I already mentioned this. Make sure we're not taking the square root of a negative number. Okay? That happens all the time. Okay, you got to make sure you never take the square root of a negative number. Right, so let's take these two functions, okay, square root of x plus 3, square root of x minus 2, and we're going to try to combine them together. Okay, the first way I'm going to do it is I'm just going to add them up. All right, so remember what I just said. Okay, make sure we're never going to take the square root of a negative. So with the square root of x plus 3, what kind of numbers could I pick for x? 3 would be one number I could pick.
I would say then you don't have square root.
Okay, so what kind of numbers can I pick? Anything, it's going to be anything from this number and up.
Above the 2.
Anything from -3 and up. Right, so you can write it that way. Or the notation that sometimes our book will use, I might have showed you guys this a little bit. You can pick any number from -3, bracket means including -3, up to infinity. It's the same thing, okay? But they're going to use this notation later on, so we should get used to using it too. How about for g of x?
Anything other than 2.
Anything what?
Other than 2.
Anything except 2? We couldn't do -10. Like that would not work. Yep.
Maybe x is less than or equal to 2?
Well, -10 would fall in that category. That is less than or equal to what you said. So not quite.
Greater than or equal to 2.
Greater than or equal to 2. Yeah. You've got to pick numbers that are greater than or equal to 2. All right. If you try to pick numbers smaller than 2, you cannot plug them into that because you're going to get a negative under the square root. All right, so the way we could write that is any number from -2, bracket including -2, up to infinity. Okay, we can't include infinity. That's why I put a parenthesis on it. You put a parenthesis on something you can't reach, and we can't reach infinity. All right, so any question on the original domains? That's important. Yep.
Why did you put -2 and 2?
Oh, thank you. Yeah, from 2. Yep. I was looking at the one above it. Thank you. From 2 to infinity. Right, now let's combine them together. Okay, so we're just going to add them up. And there's nothing you can really do to simplify it. Just write f of x plus g of x. Okay, square root of x plus 3 plus square root of x minus 2. Now, what is the domain here? In this new function, what numbers can you pick for x?
Above them. All the numbers.
Oh, Will? What numbers can you pick for x here?
Anything above -2.
-1 wouldn't work in this one. Because -1 take away 2 would be -3.
All real numbers.
No, if we have a number that I just said doesn't work, then it can't be all real numbers. With square roots, we always have to be careful. It's usually from a certain number and up. Fernando?
Anything above 2.
Yeah, you can pick anything above can you equal to. Yeah, so anything 2 or higher. That's your domain here. From 2 as high as you want to go. All right. So in the first one, you could pick any number -3 and higher. But in the second one, you got to pick numbers 2 and higher, right? So you got to go with, kind of think of the one that's more restrictive, right? 2 and higher would work in both. Any question why that's the domain? Yep.
How would you write that in the other form?
You could just write x is greater than or equal to 2. Yep. I just want you to see both because sometimes on my tests or in the book, they might use both. So we'll practice with a little bit of both today. All right, let's divide the two functions. Okay, so f of x divided by g of x. That's it. There's nothing you really need to do to neaten that up. Okay, we're just going to leave it like that. I know there's a square root in the bottom, but don't worry about that for this. Now, what would my domain be here? similar to the last one, but there's one extra thing we have to be very careful of. Yep, Tommy Lee?
Anything greater than 2?
Yeah, why did you say anything greater than 2? Why not equal to 2?
You said you can't have 0 and denominator.
Right. So if you look at the top, you can pick anything greater than or equal to -3. If you look at just the bottom, forget it's a fraction. Just look at the square root of x minus 2. We can pick anything greater than or equal to 2. But then look at the whole fraction. If you pick a number that's greater than or equal to 2, like 2,
You don't get a 0.
2 minus 2 is 0, which is okay. Square root of 0 is 0. That's okay. But then we have divide by 0. We can't do that. So this domain is from 2 to infinity, not including 2. Okay, so parenthesis means do not include the number. Or you could write it that way. Good. So we caught the trick. You have to be very careful with that. Good job. Right, let's try this one. Okay, we're going to graph f of x divided by g of x, and I want to find two things: the domain and the range. Right, so what that's going to become is the absolute value of x, that's f of x, divided by g of x. So it's the absolute value of x over x. Okay, this graph's going to look a little different than anything you've really seen before. All right, so remember absolute value, it's under math, number, absolute value. So absolute value of x divided by x. Zoom 6 is going to be fine. And that's the graph we get. Okay, the reason why you get that is try a couple numbers in your head. Try plugging in like 2. Jamie, what's the absolute value of 2? 2. And what if you take 2 and divide by 2? You get 1. So you try 6. Absolute value of 6 is 6. Divide by 6, 1. Okay, so you're always going to get 1 if you pick a number that's above 0. If you pick a number below 0, like -3, okay, absolute value of -3 is positive 3, divided by -3 is -1. So the range here is very limited. There's only 2 numbers in the range. Okay, what are the 2 answers that you always get when you plug something in for x? 1 or -1. That's it. Okay, that's never happened before. Okay, we only have those 2 numbers. And how about the domain? What values am I allowed to plug in for x?
Greater than 0.
Yeah?
Anything that's not 0?
Good job. Anything except 0. All right, so you could write all numbers except 0. Okay, all numbers except 0. Okay, and on the calculator, you could try 0 and see what happens. Go to your table, type in 0. It says error because you can't divide by 0. But you can divide by anything else you want. Okay, any question on the domain and range there? So the picture can be really helpful. Right, so if you need to, make sure you always graph it, take a look at it. All right, so another way we can combine 2 functions is what's called composition. Okay, and basically with composition, all you're doing is, instead of adding, subtracting, multiplying, or dividing, is you're taking one function and plugging it in for the letter in another. Right? So I'll show you how that works. Right, this is the notation for composition. G of f of x. So it usually has 2 letters just like that. Okay, anybody remember this from Algebra 2? Composition? People? Okay. All right, so this is how you find g of f of x. Okay, even easier, let me start out with a number. Okay, what if I said to find g of 4? What does that mean to do?
Add.
Yeah, in the function for g, take the x and replace it with 4. And simplify if you can. Okay, if I said to find g of 9, okay, what does that mean to do? Yeah, square root of 9. In the function g, take x and replace it with 9 and see what you get. Well, g of f of x. Okay. In the function for g, I'm going to do the same thing. I'm going to take, and first I'm going to just write what f of x is. So it's g of, okay, let's look at what f of x is. X squared plus 3. Right, so now in function g, instead of plugging in a 4 for x, or instead of plugging in a 9 for x, I'm going to plug this in for x. Right, so it's the square root of, okay, and it's not a number this time, not 4, not 9. It's x squared plus 3. Right, so I took a function and I plugged that in for the letter. Let's see. Question? Derek? No? Okay. All right. And let's try it the other way around. Instead of g of f, let's try f of g. Right. So what I do, just start by writing your outside letter. And then they want g of x. Okay, so we're going to look at what that is. Okay, Pat, what's g of x? What's g of x?
The square root of f.
Yep, it's the square root of x. All right, so in function f, everywhere we see a variable, we're going to replace it with what's in the parentheses. Anybody think they could tell me, you don't have to simplify it, but tell me what you would get if you start that process? All right, so first thing, we looked at what g of x is. It's the square root of x. So in function f, replace the letter with this. Okay, what would you get if you do that?
Good.
Yep.
Square root of x squared plus 3.
Right. You're going to take everywhere you have a letter and replace it with what's inside the parentheses. Okay, usually we do a number, but in this case we're just doing this letter. Square root of x, fill that in, squared, plus 3. Okay, what would that simplify to? Yeah. Yeah, the square root and the square cancel, and we just get x plus 3. Okay, so an important point here is g of f of x and then switching it are not the same. G of f and f of g come out different, usually. If they do come out the same, that does mean something special, but don't worry about that. Okay, another symbol that you might see is this symbol. They do a G, a small circle, and then an F. I don't use this notation as much on the test. I'm going to use the notation on the right. G of f of x. Okay, but that, I guess, is a little bit shorter to write because it's just 3 things. G, circle, F. All right, so if you see that in the book, just don't get confused by that. And we're going to try a couple more of the composition. So if you're kind of a little shaky, don't worry. Okay, and as we try them, what I want to do is find the domain. All right, so before you compose them, each original function has its own domain. But once we put them together, what is the domain now? Okay, it changes a little bit. Right, so first thing we want to look at is the inside function. Okay, by inside function, I mean this one. Okay, or in the one above it, it's this one. Okay, the one that's inside the parentheses. Okay, first thing we do is we're going to eliminate any values we need to from the domain of the inside function. Right, so we're eliminating values. What would we be looking for? Is there any value that causes us to divide by 0 if we had a fraction? We'd eliminate, say, nope, can't use that one. All right, is there any square roots? If there are square roots, we'd look for things that would give us square roots of negative numbers. Okay, we'd say, nope, can't use those. All right, so start with that inside function and rule out anything you need to from that. Okay, that's step 1. Okay, the second and the last step, look at your composed function, okay, the final answer that you just got. So in this case, that was one of our final answers. That was the other one. Look at this function and say, okay, is there anything else I have to be careful of here? In this bottom one, there isn't. Okay, if I say to myself, can I take any number and add 3 to it? Yeah. I can take any number I want and increase it by 3. So part 2 wouldn't even apply to this one. But this one, okay, I have a square root. Okay, anytime I've got a square root, I've got to make sure that I'm not taking the square root of a negative. All right, so we'll try a couple examples. All right, so there's 2 functions, and let's practice with just a number first. Okay, just to make sure everybody understands kind of how we're plugging stuff in again. All right, so this says to find f of g of 9. Okay, so start on the inside, g of 9. Okay, if I want to find g of 9, what does that mean I'm going to do?
Put the 9 in the actual.
Yep, put the 9 in, and what's going to be my expression when I do that?
3.
Before you get 3, you'll have...
Cube root of 9. I mean, gonna make the sign and then put 9.
Square root.
Yeah.
Yeah. Yep, I got you. Square root of 9. Any question on that? Okay. Now we'll simplify the square root of 9. We get 3. And Derek, now what am I doing with that 3? Yeah, I'm going to plug it in for x in the f function. Okay. And what would you get if you do that? 4. Okay, so there's a basic composition using a number. Now let's try it with a letter. All right, so Cameron, what is g of x?
Square root of x.
Yep, it's the square root of x. Okay, so what I'm finding is f of the square root of x. So in function f, fill in square root of x for the letter. So we get square root of x plus 1. Okay, don't worry about the domain yet. We'll do some with domain. I just want to practice this a couple more times. Okay, and the second one, g of f of x. All right, so Tyler, what am I finding here? G of, what is that?
Isn't that just f of x?
Yeah, and what is our f of x?
X plus 1.
Yeah, x plus 1. Okay, so in function g, everywhere you have a letter, change it to x plus 1. Okay, Dalton, can you tell me what I'd get if I do that?
Square root of x plus 1.
Yeah, and is everything under the square root, or?
Yeah.
Yeah, everything's under it. So if you read these out loud to someone, they might sound the same. Square root of x plus 1, square root of the whole thing, x plus 1. Just be careful. Okay, any questions on that? Now let's try one with the domain. So I'll do the same thing. We'll find g of f, f of g, and the domain. Okay, you don't have to worry about this other notation. Might see it in the book a little bit, but on the test I'm not going to use it. All right, so start out with g of f of x. So in that case, that's g of, go find f of x, x squared minus 1. And Brian, what would I get if I plug in x squared minus 1 into g?
The square root of x squared minus 1.
Yes. Anytime you add or subtract under a square root, don't try to cancel things out. You can't do that. All right, so now let's see if we can figure out the domain. All right, so step 1. Okay, start with the inside function. Okay, let's look at that. Okay, the inside function was f of x. Is there any restriction on the domain for x squared minus 1? Ask yourself, is there any number that you are not allowed to square? So if you do 0 times 0, you wouldn't get an answer for that? Yeah, so you could square anything. All right, so there's no restriction on the original inside function. Questions on that? All right. Second step. Look at the composed function. Okay, look at your final answer and see if there's anything we need to be careful of there.
0, maybe, no.
0 would be a problem here. What do we want to happen under this square root? We're going to make sure x squared minus 1 is what?
It can't be 0.
It's got to be positive. Okay, so I think of it this way. I want to have what's under this square root positive. If it goes negative, we've got a problem. Okay, so I want x squared. I'm just going to plus 1 on each side. So what kind of numbers can I square? And the answer will come out greater than 1.
0.
Actually, it could be, this could equal 0. That's okay. Could be greater than or equal.
Greater than or equal to infinity. 0 and infinity.
No, can't use 0. 0 would be a problem. If you square 0, you wouldn't get something bigger than 1.
Wouldn't it be all real numbers except 0?
A half wouldn't work either. Like if you did a half squared, a half times a half would be a quarter. That would be. So we have to pick numbers so when we square them, they come out bigger than 1 or equal. Yep,
So it would be 1, wouldn't it?
just 1.
Or then like anything greater or equal to 1.
Yep, that's half of it. So the domain is anything from 1 to infinity.
All the counting numbers are real.
Or, that U symbol means or. There's also other numbers you can square that will come out bigger than 1. Think like negative 5 squared.
Yeah, all the negatives.
So like, would it be all numbers like greater than 1?
Greater than 1 and
Greater than.
and less than negative 1. Yeah. So you could pick anything from negative infinity up to negative 1, and you can include it, but you can't pick anything between negative 1 and 1. You can't pick decimals. Okay? And then you can pick anything from 1 to infinity. That's probably the trickiest kind that we would ever have.
What's that U between?
This means or. You could pick
Oh, okay.
this number or this number. So anything you want from negative infinity up to negative 1, or from 1 to infinity. If you square those values, it will come out greater than or equal to 1. Okay, and doing it the other way is it's going to be easier. Okay, f of g of x. Okay, so we're finding f of the square root of x. In fact, I think we did this one already. So in function f, fill in the square root of x. I think Tyler told us earlier what happens here. If we square root and square, what happens?
So it goes away.
Yep, cancels out. And all we get is x minus 1. All right, now if you just look at that, look at the final answer. Is there any number you're not allowed to decrease by 1?
What?
No. Yeah, you can decrease anything by 1. But remember the first step. Go back to the inside function and take a look at that. And see if there's anything, bless you weren't allowed to use. Okay, here's the inside function. Is there any restriction on what kind of numbers I can take the square root of?
Anything less than 0.
Yeah, it can't be less than 0, so what does it have to be?
Greater than or equal.
Greater than or equal. You wouldn't get that restriction just by looking at the final answer, but the final answer is only half of it. Look at the inside function. Any restrictions there? Yes. You've got to pick numbers greater than or equal to 0. And in fact, if I graph it on the calculator, I won't graph the final answer. I'll graph the step right before it and watch what the calculator does. Graph the square root of x and then squared. Square root of x squared, what is it, minus 1?
Yeah.
Notice the calculator starts at 0 and it only goes to the right. It's not graphing this negative part because that's not part of the domain. If you plug it in as the final answer, the calculator won't know that you had a square root originally because you just canceled it out, you made it disappear. Calculator would graph, I'll show you what it does if we graph that. It's just going to graph the whole line. It doesn't know there was a square root there that canceled out. Okay? So you have to go back and look at that inside function. Yep.
So do you even have to look at the second one? If you just go back and look at the inside function, will that just give you the answer anyways?
Sometimes you do, sometimes you don't. In this one, you don't. In the last one, that's where we got our restriction from. It was the final answer. So in the last one, yes, you did have to. Remember, in this one, there was no restriction on the inside one. Here there is. Okay? Sometimes there's only a restriction on one, sometimes on both. Yep.
Can you write that one with the negative infinity the other way?
This one?
Yeah.
So it would be x is greater than 1 or x is less than negative 1. Yep. Greater than or equal, sorry. And last thing we can do with composition, if we can find the domain, we can also find the range. Well, to find the range, the first step is you find the domain. Okay, so the domain, those are the values you're allowed to plug in for x. Okay, the range is when you plug those numbers in for x, what kind of answers do you get for y? Do you get positives? Do you get negatives? Okay, what do you get? That's your range. I use the graphing calculator to help me out with that. Right, so we'll try this one and see what we get. So let's find, let's do g of f first. This time I didn't put any x squareds in it because I just wanted to keep it a little simpler. All right, so I'm finding g of the square root of x. So in function g, fill in square root of x for your letter. So now we go back and we look at two things. Start with the inside function. Okay, any restriction on f of x?
Can't be zero.
0 is okay.
Negative.
It can't be negative. So what numbers do you pick?
Greater than or equal to 0.
Good, greater than or equal to 0. Okay. Look at the final answer. Are there any restrictions here? Think. Any restrictions on the square root of x minus 3? What kinds of numbers you can pick?
Greater than or equal to 0.
Yeah, anytime you've got a square root, you have restrictions. Okay, but it's the same restriction in each. Okay, the inside function, you have to pick numbers greater than or equal to 0. Final answer, you have to pick numbers greater than or equal to 0. So the domain is any x from 0 to infinity. In other words, no negatives. Okay, and the range. Let's graph it. Okay, take a look at it and see what it looks like. Right, so we get the square root of x minus 3. Minus 3. Okay, so we're looking at how high and low this function goes. Okay, it's going to continue kind of on this very slow increase, okay, forever. So how high does you think this would go? You just keep going. And if you want to check it, start plugging in big values for x. Okay, it's at 2 when x is 250, it's up at 12. When it's at 9,999, it's at almost 100. Okay, it's not stopping. It's still going up and up and up and up. So there's no maximum. But what does it look like the lowest value is here? Yeah, it is negative 3. Right? So you could zoom in if you want to see it a little better. So this graph has a low value of negative 3 for the range and goes up forever. So that's negative 3 to infinity. Okay, any question? Yeah.
How would you write the range in the other notation?
X would be any number greater than or equal to negative 3. From negative 3 up. Right, any question on that one? So graphing calculator, really, really helpful to find the range. For now, I'm gonna hold off on doing f of g of x. Okay. Keep in mind though, when you switch the order, domains and ranges change. Okay, this one, I already showed you this yesterday. Okay, we talked about what happens if you change all your x's to negative x's. Okay, what you get is a reflection over the y-axis. Okay, so that's an example of a reflection over the y-axis. So it's when you change x to negative x. Like in this example. Okay. Try graphing each of those, and they'll be symmetrical over the y-axis. All right. So I said the same thing right here. If you take all your x's, replace them with negative x's, you get a reflection over the y-axis. Right, and I won't spend too much more because we talked about that yesterday too. Right, yesterday we also talked about all these transformations. Okay, this part's important for the test. There's one question on this. Right. All those transformations that I taught you, they don't just apply to a parabola. They apply to anything. So like if you had this, what does that do to the parabola, the plus 3 at the end? Shifts it up 3. What do you think a plus 3 would do on a square root function? It would shift it up 3. All right. If I took something like this, say 2x squared. What is a number in front of it? Vertical stretch by a factor of 2. What do you think that would do? The vertical stretch by a factor of 2. Okay? All these numbers, we did this yesterday, Tyler. So it's not something that makes sense to you. Look at that. Yeah, that was yesterday's lesson. So whether you're shifting up and down, shifting left and right, everything works the same in all kinds of functions. Not just parabolas, not just square roots either. Okay, I could do any function. We don't know trig functions yet, but if you did sine of x, which is a trig function, and sine of x plus 3, that's going to take the sine function and shift it up 3. Okay, so when you add a number onto the end. All right, so here's kind of the generalization of all our transformations. If you stick a number in front of a function, that causes a vertical stretch or a shrink. We always describe it as a vertical stretch when that number is a fraction, like 1/3, 1/2, that's when it would shrink. Numbers bigger than 1, it would stretch. Okay, if you take any function and put plus or minus a number on the end, any function, that will shift it up or down. Plus is up, minus is down. All right. If you take a function and inside the parentheses, you do x plus a number. Okay. Like yesterday we did something like this. Or you could do something like this with a square root. If you put a plus 2 under the function or in the parentheses, that would shift it left. In this case, left 2. If you put a minus inside the parentheses or under the function, that would cause it to shift right. Okay, so the same thing we did yesterday, I'm just kind of generalizing it. If you throw a negative in front of a function, like this, that causes a reflection over the x-axis. Okay, so putting a negative in front, that flips it over the x. Putting the negative on the inside, like this, putting that negative in the parentheses, that causes it to flip over the y-axis. Okay, any question on the transformations? So it's the same thing you really learned for parabolas. Just now I'm saying you can do it with anything you want. Okay, and I'll probably give you one similar to a square root on a test and say, how is that shifted? Did it shift left? Did it shift right? Did it stretch? Okay, what happened? So these will be our last one or last two. We'll see how much time we have. Okay, looking at that graph, okay, I want to do, let's just make this a little easier. I want to do that to it. Okay, I'm not giving you a formula for it. All I'm giving you is a picture. I want to know what this plus 1 is going to do and what this minus 3 is going to do. Okay, start with plus 1. Anybody tell me what that plus 1 is going to do? Yeah. Yeah, that's going to shift left 1. And how about the minus 3? Down 3. This isn't a parabola, but it doesn't matter. I said you can do this on any function you want. It doesn't matter what the shape is. So all I want you to do here is draw this function. That's function f, shifting it left 1 and down 3. So take every point, left 1, down 3. Left 1, down 3. So there'll be a problem in the homework where they give you a picture and then just ask you to shift it somehow, either left and right or up and down. I sketched the graph above. Any questions on that one?
Redraw the middle over there.
What's that? So every point went left 1, down 3. Left 1, down 3. Left 1, down 3. All right. So tonight, we're going to do something a little different. Okay, so I mentioned we're going to do the take-home. Okay, so I'm not going to give you the regular assignment I was going to give you. So we've got our take-home test. The test is on 1-3, okay, to 1-6. Okay, it will be due by 8:35 tomorrow. Okay, if you don't have it in by 8:35, that's a 0. Okay, so you've got to make sure you turn it in by 8:35 tomorrow. All right, so we have the assembly. Most likely we'll meet here first. Okay, if we don't meet here first, I'll be here by 7:20. So just come drop the test off at any point before 8:35. Start a class. Okay? And that's the only homework tonight.